Students, this is the Unit 8 multiple choice preparation, taking a look at the starred problems. For this section, we're asked to find the volume for each of these. So as you go through these, it's important that you shade the bases if it's a cylinder and prism, or shade the singular base. See, there's two bases there, and there's one base here. You shade the singular base of pyramids and cones. So for pyramids, for prisms and cylinders, it's volume equals base times height. Pyramids and cones, it's volume equals base times height over 3. And remember that B stands for area of the base. So we're going to do this number 6 in pi form. So that's the base. Let's physically circle it and shade it. So I'm going to bring an arrow down here and identify my base is a circle. Therefore, to find the area of the circle, it's pi r squared. I physically trace my radius. I don't use my eyeballs. I physically trace it. And you're going to notice that the whole thing is 4. Therefore, my radius is 2. So I find my capital B is 4 pi. I plug it back up in here. That's 4 pi times my height, which I have straight down there, over 3. Clean that up. Watch out for units, which are going to be kilometers cubed this time because it is volume. Once again, I want to find the volume of the shapes here. And if they are prisms, there are 2 bases, like this one. If it is a pyramid, there is 1 base. For the 2 bases, volume equals base times height. Pyramids, volume equals base times height over 3. So I take a look here, I find my bases first. And remain bases must have these 3 qualities, C, P, R. They're congruent, they are parallel, and they're connected by rectangles. So in number 11, my bases are the front and the back trapezoid. Let's trace one of them. So my volume here is going to be base times height. That's capital B, meaning area of, times my height, which is the distance between the bases. So if my bases are the front and back trapezoid, my height here is that 10. Now we're going to circle this base and ask ourselves, how do we find the area of a trapezoid? The area of a trapezoid is the average of the bases times the height. So I go here, I check my bases. 1 is 5, plus the other one, trace it. Is going to be 8 over 2 times my height. If I drop down there and I take a look very closely, right there at that dotted line, that arrow points to it, that is 2.6. So our height here is 2.6. And do your number crunching, and all of that is just your capital B. You plug it in there, times the height, watch for your units. Pause the video, finish, check your work. Taking a look at 13. Again, you're looking for your bases here. Your bases are CPR, congruent, parallel, and connected by rectangles. In this case, your bases are these two triangles. These two triangles are congruent, they are parallel, they have nothing but rectangles connecting them. So I write volume equals base times height, because it's a prism, not a pyramid. My height is the distance between the bases, which in this case is going to be 4. My base is a right triangle. Let's pull this out. That's 3, that edge is 4, and that is 5. The area of a right triangle is leg times leg over 2. One leg is 3. The other leg is 4 over 2. That is going to be your base. You want to finish your work there and then check it in the back. Watch your unit. Taking a look here at 23. Says each pair of the figures is similar. So is similar means already has the properties of congruent and ratios equal. Use the information to find the scale factor. Scale factor is one dimension of the figure from left to right. Okay, use the information given. So we look at what we're starting with, and in this case, we're starting with the surface areas, which means when we have one dimension, x to the first, y to the first, our second dimension, x squared, y squared, and our third dimension, which is x cubed, y cubed, we are looking for, or working with, starting with our second dimension ratio. Why? Because it is area. So we're going to start in that position, which means we're looking for, as we reduce this, we're going to look for perfect square. And you want to start by dividing both numbers by the same number. If it has pi's, the pi's automatically cancel. So I'm going to start by dividing by, I see 4 goes into both. I divide by 4, I get 100. And then divide by 4. And I get 64. Now, if you look carefully, those are both already perfect squares, which means we have found our x squared and y squared position. Now to work backwards, you just ask yourself, if x squared is 100, what would x be? If y squared is 64, what would y be? And that would be your first dimensional scale factor. Finish that up, see the one on the right, and check your work. Now these are volume. So watch carefully. We're going to write our 1D, x to the first, y to the first, 2D, x squared, y squared, 3D, x cubed, y cubed. We're working with volume. And we're going to be hunting in the third dimension. We are in volume here. So we're already in what's called the x cubed, y cubed. So I recommend that you're familiar with your cube roots, at least 1 through 10. So you're familiar with those. Why don't we draw those in the margin here? 1 cubed, 2 cubed, 3 cubed. Go right down the line so that you have these handy and they're easier to spot, because you're not as familiar with these as you are with squares. Go ahead if you need to get out your calculators. Oops, 4 times 4 times 4. Memorize this backwards. That one's 64. That one's the 2. 5 times 5 is times 5 is 125. 6 times 6 times 6 is 216. 7 times 7 times 7 is 343. 8 times 8 times 8 is 512. 9 times 9 times again, 729. And then 10 times 10 times 10, of course, is 1,000. There's your list of the first cube roots. You're going to be hunting for those. Why am I hunting specifically for those? Because I'm in the third dimension. I'm in the x cubed. So I'm going to go ahead and start by dividing by 2 here, since that's the only thing I can easily do here. Multiplies instantly. That gets me 11. And 176 divided by 2, I get 88. And I see that 11 actually goes straight into 88, so that ends up being 1 and 8. And look, there's 1, there's 8. I'm already in my cubed root position, 1 and 8. So x cubed is 1 and y cubed is 8. Your job is to go back to the scale factor, which is back to x to the first and y to the first. You ask yourself, what number times itself 3 times is 1? And what number times itself 3 times is 8?